Day to you. This is Anagalactic bringing you another science presentation, now into spherical geometry, a brand new geometry which for some reason has never been explored to its full potential. We're doing so now and have discovered that we have a spherical surface that can be conceived as rotating. This would be to attempt a match on physical reality, where physics has discerned clearly now that the universe is entirely nonlinear. Everything that we look at is a sphere. The linear separation that we use is incomplete, and we now need to measure spherically for the first time. There are reasons why this has never been noticed, but that's covered in previous lectures. What we need to seek out now is the usefulness of the number system in the geometry we have proposed. Currently hypothetical, we can say certain things about the number system itself that we've established using Euclidean axiomatic approach to geometry. In this case, for spherical space, all we did was emulate Euclid's axiomatic steps in the composition of his linear system, resulting in trigonometry, which has been used for 2,500 years and now is used to compute curved space very unsuccessfully. It's felt throughout physics, and we're hurting bad. It's miserable. Nobody sees any progress, certainly not in the past 100 years, and into the indefinite future. We are stuck with Einstein's hyperbolic formulation of gravity. That's nonsense. We cannot be stuck with it. Einstein opened the door for us to finally see space and time together. This is what we're doing now. So the surface of the sphere, which can be thought of now as the center of the universe, that is, the surface center of the universe, is a sphere. And all spherical systems have a spheric center, not a point. We've eliminated the concept of the point. It will come back, but it has to be in a spheric context, not linear. These have to be spherically composed points. Where will those be? We're going to find out now. On the injection of energy into the sphere, it causes it to have an angular momentum. We call that rotation. But we've discovered that the rotation system in quantum space is not exactly what we would expect from a solid body sphere. So the electron, although it has been measured to be a perfect sphere, is not spatial. It manifests something other than space. And the reason I can say that so forthrightly, and I checked this just to be sure again, that the electron is not perceived or measured to have a diameter. It does not have a radius. In fact, it does not have a center. That is what we would expect. The electron is a center. It's a sphere because it's a center. But a center of what? Not a center of space. For that we turn to the proton. That is a center of space. How do we know that? Because of its effect on space. It bends it in. It pulls it. The proton exerts a pseudo-force called gravity. And that's the source of gravity. It's the proton. What then is the electron? You might make a wild guess that it's a manifestation of time to the exact same proportion that the proton is a manifestation of space. If you thought about that even for a moment, you're right. That is correct. The electron is a manifestation of time, not of space, and you have to say both. And the proton is a manifestation of space, not of time. So Albert Einstein put time into space. That can be done. But in order to do it, you have to do some gymnastics, both geometrically and mathematically, and finally mentally, that are totally insupportable. And so Einstein was wrong. What that means is that quantum mechanics is wrong. And it also means that astrophysics is wrong in everything that they do. What we're doing now is exploring the solution to that will unbind physics with a new number system that actually computes Einsteinian space directly, not using a hyperbolic inversion and not using four-tensor calculus. Those are the signs of failure. That's why you can't understand anything in physics. That's why you don't understand. The reason you don't understand anything, just name what it is you're looking at. The black hole, the Big Bang, any of the crazy names that have been assigned to that which we cannot measure perfectly, we give insane names to. That's how you recognize the blockage in physics, that they give insane names to physical phenomena. The Big Bang is an insane name. It is totally misleading. The supermassive black hole has been completely misformulated, and quantum mechanics is obviously permanently in a coma. They crow about what they're able to do on Earth. Yeah, we know. It's going to be wonderful for the governments. They're going to get quantum computing so that they can finally control the monetary system of Earth in a stranglelock that nothing will ever break. So the governments are doing fine with linear algebra. Linear algebra serves Satan, if you want to call it that, which I do since it's a scientific name. It just serves Satan perfectly. Keeps everybody blind to what's really happening so they don't know the truth. That's the main goal. But the side goal is, holy crap, another weapon. Another weapon based on the power of the proton. That's why they have proton colliders. And you might start to suspect maybe that's why they call them hadron colliders. Because that's totally confusing. What the hell is a hadron? I dare you to find out. I did. I now know what a hadron is, a boson. I know their particle soup thing. They're absolutely lost. Every measurement they get, they think is valid, but it's a linear measurement. So they are getting a partial solution. That's perfect. That's a term directly from calculus. They're getting derivative solutions because they're using linear solutions. But nothing is linear. It's nonlinear. Well, what's the bridge that will help us compute the universe? Well, if it's nonlinear, I discovered there's one other choice. You might try spherical instead of linear. So we're after the metric now. The metric is what it measures. We're saying that it's time-space. Well, is it space-time or time-space? Let's settle that once and for all. It's either one. Space-time and time-space you can visualize on a four-component system such as Einstein used. It's 4 lines. 3 of them are spatial, and 1 of them is temporal. But you actually can say it the other way around, that the 3 space components are negative and the time component is positive. This is actually how it's done. This is what makes it hyperbolic. But you can transfer from sphericity to hyperbolicity in 2 ways. With a 3-1 split or a 1-3 split on linear valence, which is plus and minus. And that will get you essentially the same hyperbola, but with space and time inverted. And that's the difference between space-time and time-space. They actually compute the same way. They use the same relationship of plus-minus between spatiality and temporality to simulate hyperbolic space, which simulates spherical space. We want spherical space directly. And so instead of a 4D system, that's a 4-dimensional linear system. We propose a 2-dimensional spherical system. So what are these dimensions? Well, we just named them. One is the radial line that goes in or out from the center, depending on if it's gravity or the flight of the photon. And that brings up an interesting question. What then causes the flight of the photon? It sounds like it's anti-gravity. That's not bad. That's almost exactly right. The flight of the photon manifests anti-gravity. It's flying in a certain direction without the influence of gravity. The photon is unaffected by gravity, so why is it traveling? It's traveling in a way that's not directly perceivable with a linear mode thought approach. The flight of the photon can only be perceived in its native space. Well, that's the light cone. But it can't be a cone. It's spherical. Max Planck proved that the surface of the sphere that I discovered has a value not of 1, which I've discerned. Mathematically, it's 1. It has to be 1. But Max Planck said that that 1 is actually light speed, and proved it. So that 1 that represents the surface of the sphere has a surface value number of 1. We're now going to explore that. So we get the linear aspect of spherical space is embedded. We now need to find it again. Where do we find the line on the sphere? The radial line is space, but now we need the spherical line. The sphere itself is the line that's orthogonal to the radial line. They're both lines, but not lines such as we normally think of them. The spherical line is all the lines, and any one of those is the calculus infinitesimal line. These are the lines we use, and that's why they're infinitely irrational. And at the same time, our line composes an infinitely irrational number line. Embedded in it is an infinite number of rational numbers. These are the geometric numbers that are used in multiplicative space for the spherical number system. It's only the rational numbers that are used in my number system. It's purely rational, but the cost is basically the infinitesimal of the cost in calculus. In other words, we need to integrate the calculus itself into a geometric calculus that embodies, by basically object-oriented programming, we have the mathematics of the calculus built into the object, so the object performs the calculus for us. That will be the result. We will have an effective calculus where we're using the integral number system instead of the derivative number system which we've always used. We use the derivative number system. So the radial line is composed of an infinite number of infinitesimal straight lines, and that's the definition of the straight line in spherical space. It's one part of the radial line, an infinitesimal part. We want the part, not the infinitesimal. We want the value of all the lines as one number. So it gives us a direction that's out. With the positive whole numbers beginning at 2, we can now count in physical space going out from the sphere. That geometrically solves the paradox of the quantum. It fully defines the flight of the photon, both as a sphere and as a straight line, geometrically, simultaneously. That's the solution then. We're looking at it. Now we want everything else. And for that we need motion. So the sphere is rotating. That generates an eigen, called the axis in our language, linear language. But now you see that eigen, that's the part of the sphere that's unaffected by rotation. We call it the axis. That is a line. This is a line with a different center than a linear line. The center of the spheric infinitesimal line, of which the eigen is 1 and now appears in relation to spherical rotation, there is a straight line called the eigen axis. And that is what we would call a line, except the center is not 0. It's 1 over infinity. That makes it a different sort of a line. It recharacterizes what the center is in terms of numbers. So that's the nature of the true line. That it in fact does not have 0 at its center, not even as a linear line. So 0 never did exist, and that's why it caused such a horrendous problem in all of our mathematics since the beginning of time. Division by 0 is fatal. And it never occurs in spherical space. There is no 0 and there's no division by 0. Everything is rational and everything is closed. So this is definitely the right space to use for Einsteinian space. To now begin to compute in true space-time, a reformulation of space-time, using this new number system, we now need to determine the metric. What do these numbers measure? They measure two things at once, which involves a mind split. We know that we can formulate space numerically, but with a reciprocal effect on the sphere. So there's a relationship between space and what's happening to the sphere itself. That sphere has the time component on it at the energy injection at the UNIVEX event, 1 Planck unit of time before the Big Bang. There was this geometry waiting for motion. So the Big Bang, whatever it is going to be reconceived to be so it's closer to the truth, it's going to have to do with this rotating sphere that has time on it. That's what's been left out of the Big Bang formulation, and in fact, all of our linear formulations leave out time. When you do that, you end up with the Einstein field equation, the Dirac equation, and the two forms of the Schrödinger wave equation, which cannot be visualized, cannot be computed, and cannot be understood, because they're attempts to close the gap with temporality. But you can't. You can't do it. They'll never make it. They can't. They are actually hamstrung. They being the physicists using linear algebra. Linear algebra is the problem. That's unacceptable to anyone who's in the industry. Their livelihoods depend on this not being challenged in any way. That's not actually true. I'm offering a better solution which does not invalidate anything else. It will not be perceived that way. It's a change to the linear basis system of the money tree, and therefore it cannot be accepted or even considered, because it might influence the money pipeline. That's a fear that no industrial scientist can overlook. Their whole reason for living and being in science is to get money. That's all they want is money. So the linear algebra system is the money cow. It's the golden calf. They can't let anything touch it. The group mind won't allow it. And so this must be rejected. Well, that doesn't stop real science. Real science goes on toward the truth and understanding, no matter what anyone is doing with their goddamned idolatrous calf. We don't participate as Israel played when they should have been paying attention to the one true God. They decided to make a golden calf and worship it with catastrophic results. Well, that's what linear algebra is. It is that golden calf. Now, yeah, I'm the potty pooper. There's nothing to fear, but they will fear it anyway. The group mind will fear it. So it does go to the human equation, but we don't care. We're going to do it anyway. Even if someone imagines that their foot is being stepped on and we all get slaughtered as infidels, that's what science does. We can't help it. We took the vow. We're going for truth. We're not going for money. You can go for money if you want. Just stay out of our way. Well, yeah. No, that's not how it goes down. No, there's going to be a cage fight with all of the non-linear people executed without mercy, okay? No hope for spherical geometry in this present day world. We are not in the present day world. We're in heaven. Get it now? So that's what we're doing. We're getting the truth of heaven so we can understand it and benefit from it. Isn't that the goal? So the first number that we have to bring in to metricize spherical space is a very unhappy number. It's the number tau. And tau is 2 pi, as you know. And tau is the surface number for the circle. But we found that the surface number for the sphere is 1. So now we have to invert the sphere in order to find out where linearity exists numerically. Where is tau? Because you can't get rid of it. You can't get rid of tau. I just received a warning on my screen that I'm exceeding some boundary in my recording. Encoding overloaded. Consider turning down video settings or using a faster encoding preset. I think it's because I'm doing an upload at the same time I'm doing this. And I don't know what effect this is going to have, but I'm sorry for that interruption. Well, that's 23 minutes. We're ready to get into the numerology, the secret numbers of the sphere. They're not secret. They just need to be moved around a little bit. We cannot have tau as the surface number. That's the linear number for the surface of the circle, is tau. We say it's 1. So where did tau go? Because you can't get rid of it. It's the radius. It's the reciprocal of tau is the radius. So the radius is where we find the linear component. And sure enough, finally, the irrationality of tau is now linearized. That's an integral solution for spheric space, or circular space in this case. What about the sphere? Well, the surface number for the sphere is 2 tau. A remarkable fact, but it is. So the relationship between the sphere and the circle is 2 to 1. That is exactly what we wanted to know. The linear part of the sphere would be considered to be the radius. And now what is it? It's 1 over 2 tau. Right? It's 1 over 2 tau. Well, that's where the if you're going to have an irrational number, it can't be on the sphere or the circle. They don't use rational numbers at all. So you invert it, and that's how you get your new number system with linearity in it. It's the radius is the irrational number. It's an irrational radius. It's 1 over 2 tau. That makes the surface number of the sphere 1. And that closes the system absolutely. And now we have full linearity in the space. It's on the radius where you would expect. And no longer is the surface number irrational. By a simple proportional inversion, we've gotten the omega circle. That is what has time on it. So to visualize how you're going to be able to see time on the ring, I began by showing you a triangle on the ring, which makes frequency 3 in exactly the same sense as the length of the circumference is now in thirds. So the wavelength is now the broken circumference. And the frequency is the broken circumference. And the circumference is broken in two ways that are reciprocal. It's broken into points, and it's broken into arcs. It's broken into arcs, all of the same length. So it's never one that would be a static sphere. So it always has at least 2 points on it, and that's the lowest frequency in the universe. So when you have one, it's actually 1 point. And everything splits now. That 1 point that you put onto the circle, which you're saying the 2 points is frequency, and the 2 new segments that add to 1 is the wavelength, is one of those segments. It's now 1/2. So if you put a triangle, you have 3 points, frequency 3, wavelength 1/3. If you put 4 points, you see how it goes. This is essentially how the ancients tried to get the number for the circle, was by progressive polygonization of the interior of the circle. Just make 3, then 4, 5 to an n-gon. That's the calculus, is the n-gon. That's where you get the infinitesimal. We've got it. We have an exact number for that. So everything is rational. You never reach 0, so there's no contradiction in the space in multiplying these numbers. The ones going onto the surface are the reciprocal of the distance number going out, and therefore time is on the circle. It's really on the sphere. So the sphere has a value of 1 when the radius is set to 1 over 2 tau. That makes the surface value of the sphere 1. What does that make the surface value of the circle? It makes it 1/2. You may recognize that as half spin. It's because we can only measure on a sphere. If we're going to measure circular motion, that's the derivative of the spherical number. In this case, it's a relation of 2 to 1. So that's interesting, that the circle has a surface value of 1/2 with respect to the sphere. Now we have an interesting situation, because now the sphere has a ring that's the derivative of the sphere, in the sense that it's 1/2 of the spherical number is the number for the circle. If we had said that the sphere had a surface value of 2, we could get away with that. but it would be more complicated, wouldn't it? Because now the surface value not being 1 changes the componency of the quantum numbers. But we already know that we actually can't do that because Max Planck proved that the number system begins at 2 for an energized sphere, that the lowest number that you can have on an energized sphere is a 2. But if you construct it so that it's 1, it makes reciprocal space, and that gets the orthogonality. So now we have the sphere with a time component on the ring is now reciprocal to space, but it's actually perpendicular, that the reciprocality is a perpendicularity. That is, it's an orthogonality, and the 2 component numbers are orthogonal. When we do that, we now have the time and space components. That space goes in one direction and time goes in an orthogonal direction on the surface of the sphere. That's the definition of the ring and the energy component of the ring, which is angular momentum, and therefore angular momentum it either is time or has the time component in it. I will tell you now, and we're going to prove in the next lecture, that that is not the time component. The time component is, however, on the ring. It's one of the numbers that we can extract from the ring. It's a good thing that we have integral numbers because we don't need sine and cosine. Sine and cosine are embodied in the surface number of the circle, which is now 1/2. With respect to the sphere, this is going to give us what we want. And time is either going to be those 3 numbers that make the frequency, or it's going to be the 1/3, which is the new definition of periodicity, which is the time component. As you contract frequency, you raise the energy. I think you're aware of that. When the frequency is contracted in time, so there's more frequency per unit of time, you have an increase of energy. So the increase of frequency is the increase of energy. Max Planck discovered that that is in fact the case. And those numbers are quantized and begins at 2. As always, that's a first counting number in unitized spacetime. The surface of the sphere is spacetime equals 1. The numbers going out are space, and the numbers which we thought were going in, which is impossible, they're going orthogonally on the sphere, that is in, and that's the other component. However, both numbers are proportional, and they're reciprocal to each other. So we haven't found time yet. Have we found space then? We cannot say so. The space number does not have any direct relationship with time yet, and we have to find the relationship in time on the ring on the sphere that affects how space propagates. It has to propagate reciprocally to time. What does that mean? How can we get the metric? We're measuring space-time directly with a split number entailing a split in your mind. You're going to have to see both. We're going to have to see it together if this is going to be science. It's going to have to be geometric. It's going to have to be provable. We're well on our way now because we have the direct relationship between the circle, the ring, which has the energy component on it. It's not in space, it's in time, and time is on the sphere. So, in the next lecture, we'll be covering the relationship between the spherical surface number of 1 and the ring number, which is now 1/2. And find out how that affects space. And from that, we'll see them both in their true relation. Amazing, but that's where we're at. We'll be right back. That's 35 minutes. In the next lecture, we'll be continuing to explore the geometry of the ring, which has a relationship to the eigen. And we're going to get more insight into the flight of the photon and into quantum mechanics from looking at this, because we're now looking at the truth of heaven. We'll be right back. Stay tuned to Anagalactic.